would like to introduce our second speaker in this session, Mr. Soo Chang. He is from Seoul University, and he is a student of one of my good friends, Dr. Kang from Seoul National University. I would ask Mr. Kim to introduce himself for a couple of minutes, and then he's going to start.
Glad to see you, everyone. My name is Soo Chang. I'm in a doctorate course in Seoul National University in Seoul. As the professor said, my professor is Kang. Yes, I am studying about the evaluation of the fabric characteristic using image technology and stereo vision system. So my dissertation of master degree was the objective evaluation of raw cotton using image technology and neural network. Now I will start my presentation. Today my presentation is new method for the objective evaluation of fabric surface, Waviness. The content like this. The surface smoothness of fabric is very important for its aesthetic appearance and for the consumer's choice. So most of the undesirable ruggedness may be caused by the seam pucker and wrinkle. Therefore, the fabric and garment manufacturer have made considerable efforts to suppress these problems and also try to establish the testing method with which the surface ruggedness of fabric due to wrinkle and seam pucker could be evaluated objectively, easily, and rapidly. So, a variety of test methods was designed to measure fabric appearance. So, the existing testing method is AATCC test method. This method was widely used and inexpensive, but this method is subjective and sensitive to biases in perception. So this is not right. So the objectives of this study is to establish the new evaluation system for automatic, objective, reliable, and passive and active measurement of fabric wrinkle smoothness and seam pucker. And finally, we try to substitute AATC's test method to Object 1. We use this system to avoid the deformation on soft surface of fabric. The non-contact method and fractal geometry is applied to evaluate the surface quality. So the contour of each specimen surface has been obtained using stereo vision method. This figure shows the main constitution of the system. We place the fabric on the XY table and we take a picture using CCD camera, two cameras in the degree of 45, and yeah, controlled by computer. We have to calibrate it first to use camera system. So, like this method, we compute the calibration parameters, and finally we compute 3D coordinates by using this method. And using absolute 3D coordinates, we have to calculate fractal geometry. We use fractal geometry principles. Fractal geometry is new method to deal with the randomness and irregularity of the natural structure. Fractal surface has two. When the surface is perfectly flat plane and has the dimension 3 close to when the extremely rugged surface fills most of the space. So we can calculate the degree of out of the plane. So this equation is to calculate the fractal dimension. D is fractal dimension. So higher ruggedness has a higher fractal dimension. So the processes of calculation of the fractal dimension are illustrated schematically. This is X direction cross section method. The left is the cross section method in X direction, Y direction, Y direction, and Q count method. There are three methods. This is one example of our system. This figure is the fractal dimension of the fabric. This figure 2.0126. So because this fabric is perfectly flat, it has to become two. But this fabric has the ruggedness, so it has to become more than two. So we can take a picture using camera, many fabrics, so we can calculate this figure. So we compare which fabric is more rugged. We can know. This is a reconstructed 3D wrinkle specimen. The fabric specimen with severe wrinkle show higher fractal dimension compared to those of smooth fabric, surface fabric in all three directions, X, Y, Z direction, and cube counting method. So after we repeated many experiments, we found that the subject AATCC method don't have regular intervals. It is an inevitable result from log 5 standard replica system, and it is obstacle to the linear and quantitative evaluation. So we suggest this. We suggested that we should substitute AATCC wrinkle and simple grade with the object our system, our method described in our study for more precise and linear scale evaluation. It has regular intervals. This is the same smoothness appearance. Simple curve like this. And we also suggested this subjective evaluation with the same intervals. We suggest 5 grade and 10 grade. But subjective AATCC method have only 5 grades. It has the subjective subtle and subtle. So the grade by fractal dimension is sensitive to subtle difference in surface smoothness of the fabric. Each step in grade has a proportionality with the roughness of fabric surface, which cannot be materialized with the conventional subjective method. So, conclusions. We used to measure height of fabric surface with if and 11 feet. Fractal geometry was applied to evaluate the surface ruggedness of fabric, wrinkle, and seam pucker objectively. Also, we finally do objective 5 grading and as well as 10 linear 10 grading method for fabric, wrinkle, seam pucker, smoothness appearance have been suggested to rectify the subjective AATCC test method. We submitted to the AATCC. My presentation is I have some brochure to introduce our system. Please take it if we want. I pressed it.
Thank you, Mr. Kim. I would like you to join me here for the end of the session questions. Please join me to thank Mr.